Okay, welcome to a video lesson that we're going to do today. I hope your first day of at-home learning yesterday went well. In this lesson, we're going to go over the equation of a circle. I'm hoping that's going to set up pretty similar to how we do lessons in class. So I'm going to go through a note with some examples. You're welcome to pause the video at any time so that you can either take a note or you can work ahead of me, try the examples on your own like we might do in class. And then on Google Classroom, I've posted some practice problems from the textbook. So you can do those like we would in class. And then just like in class, we also have a short quiz to kind of check in on your learning. It's going to work the same way here. You'll go to a Brightspace link and it'll just be a short few question quiz on circles, and then we're done circles for the year. So I'm hoping that all is only going to take you around 75 minutes to 2 hours. It's just the length of a normal math class. We would normally teach circles in one day. Wish I was teaching it to you here in school. It's more interactive, it's more fun for all of us, but we're going to do the best with what we have. So let's get started. I'm going to change the view on the camera. So as always, our lessons have a title and a date. Today we're going to learn about the equation of a circle, and the date that I'm hoping that you complete this on is September 18th. What is a circle? I think we all know what a circular shape is. I've got a coffee mug here. It's going to be way too zoomed in. There's a circle. But the official mathematical definition is that a circle is a set of points in a plane. So a plane is kind of like a 2D. You can think of a graph as being a plane. And a circle is any set of points that are the same distance from a fixed point, which we call the center. So a circle is any group of points that surround a center. The only other definition that we're going to need today is what a radius is. And a radius is the distance from any point on the circle to the center. So a circle has infinite radii, that's plural for radius, and it's just a distance of the line from the center to the edge of the circle. So again, if you want to pause it to write down any of these definitions, please feel free. Obviously, you'll also have the video to check back. The equation of a circle, so a line we know is y equals mx plus b. We've done a lot of work with the equation of a line in grade 9, but lots of shapes and curves also have equations, and the curve of a circle is x squared plus y squared equals r squared, where r stands for, as you can probably guess, the radius of the circle. All the circles that we're going to work with in grade 10, they're all centered at the origin. So I'm going to pop over to Desmos and show you what I mean by that. So here I am on Desmos, which is our graphing calculator app. You can try this on your own at home. So I've told you that a circle is x squared plus y squared equals r squared. What I'm going to do is I'm going to show you what happens when I change r. So here's my circle. My first circle has a radius of 1. So it's exactly 1 unit to go from the center to any point on the edge. As I increase r, so for example, if I make r 5, then our radius is 5 units. So any line that I made from the center to the edge, would be 5 units. So r squared is what's on the right side of the equation, and radius has to be positive because all circles have a positive radius, a positive distance from the center to the edge. So that's really all we need to know about circles. Every circle we deal with, the center is always going to be at the origin. And the radius is going to define the exact size and shape of this circle. So let's move back to our note. And just like always, we're going to do a couple examples. So our first example is we're going to write the equation of the circle with a center at the origin and a radius of 2. So that's example 1a. So we know, and it's always good to start with a target. What are we trying to get to? Well, I want to get to x squared plus y squared equals r squared. That's our target. That's the form of the equation. And I know that r is 2. So I'm going to plug in 2 from r and then simplify. So x squared plus y squared equals 4. And that's the equation of a circle. with a radius of 2. So unlike a line where we need to know both the slope and the y-intercept, for circles centered at the origin, we only need to know one fact, which is r, or radius. And we just simplify, and there's the equation of the circle. We're going to move to example 1b. This time it's a circle with a diameter of 16. A diameter is the distance all the way across the circle going through the middle. The diameter is always twice as long as the radius. So r equals d over 2. The diameter is all the way across the circle, but we would prefer r. The radius will then be 8 units. So again, to find the equation, it's just x squared plus y squared equals r squared. This time I know that the radius is 8, so I'll plug in 8 for r. And now I'm just really evaluating the right side, so x squared plus y squared equals 64. Okay. So again, whenever we have the equation of a circle, we're going to have x squared and y squared on the left, and then some number, which is the radius squared, on the right. The last example, the radius is a fraction. So again, always start with the target. Always start with a goal in mind, and our goal here is x squared plus y squared equals r squared, for example C. This time the radius is a fractional length. It's 2/3 of a unit. And that's no problem. I can square fractions. And what that really means is I'm doing 2/3 times 2/3, which means I'm just going to square the top, 2 times 2, and square the bottom, 3 times 3. So I'm going to have x squared plus y squared equals 4 over 9. So if we're squaring a fraction, what's really happening there is, remember, a fraction, if I'm squaring something, I'm just multiplying it by itself. And we know that 2/3 times 2/3 is just 4 over 9. So that's kind of what's going on behind the scenes, but we can just remember to square the top and square the bottom. And that's an equation of a circle where the radius is 2/3 of a unit. Okay, we're going to move on to our second example. Again, if you'd like to look at what some of these circles look like in Desmos, you could punch in these equations and you should see circles with the radii and the diameter that we've specified. Okay, we're going to move on to example 2. In this case, I've actually given us the equation of the circle, which is x squared plus y squared equals 16. And I want us to state the information about the circle. So the first thing I want to know is the center of the circle. Well, every circle that we're working with this year, the center is always going to be at the origin, which is when our x-coordinate and our y-coordinate are both 0. So any circle that has this form, x squared plus y squared equals r squared, is going to have the center 0, 0. So that's almost a giveaway question or a giveaway mark. I want to know the radius. Remember, the equation is x squared plus y squared equals r squared. So I know that r squared equals 16. So what's r? Well, how do I get r by itself? I have to do the opposite. The opposite of squaring is to square root. So square root both sides. The square root and the square cancel out. And so I know that the square root of 16 is 4. Okay, so if the r squared is 16, then r must just be 4. That's the radius of our circle. Next, we're going to find the x-intercepts. Well, if I'm traveling, and I'll put a little graph here on the right so we can see. If I'm, remember, the radius means it extends 4 units from the center in all directions. So to find the x-intercepts, that's where the circle crosses the x-axis. You might never have seen x-intercepts plural, but if you can imagine the circle, and we're going to draw it in a second, a circle is actually crossing the x-axis twice. So if I went to the right 4 units, I'd get to 1 x-intercept. We can label that point 4, 0. But if I went to the left 4 units, 1, 2, 3, 4, I would be at negative 4, 0. So if I know the radius, then I also already know my x-intercepts, which in this case are 4, 0, and negative 4, 0. And I want us to write our intercepts as points with x and y coordinates. But we know everywhere we cross the x-axis, our y value is just going to be 0. Same thing, the y-intercepts are going to be just as quick. Remember, I can go 4 in any direction from my radius. So here I go 4 up, I'm at 0, 4. I go down, I'm at 0, -4. And so my y-intercept, and again, there are two of them because a circle crosses the y-axis twice, unlike a line, which only crosses at most once. So my y-intercepts are going to be 0, 4, and 0, -4. The last thing this example is going to ask us to do is just to sketch the circle. Sketch means it doesn't have to be perfectly exact. I'm not a perfect circle drawer. We'll practice drawing circles. Let me be a competition when you guys come back to school, see who's the best circle drawer. It's definitely not me. Sketch just means a rough approximation. So I'm just going to draw a circle that goes through all of my key intercepts. So bear with me here. I'll give it my best shot. So that would be the sketch of my circle, and that equation was x squared plus y squared equals 16. The radius was 4. That means any line that I draw from the middle has a length of 4 units, and then it goes through those 4 intercepts. So what's cool about a circle is if I know the equation, if I know the radius, I can find all the intercepts, 2 x-intercepts, 2 y-intercepts, and I can sketch it. I only need that one piece of information, which is either the radius or the equation. So sketch the circles, and now we've done that on my separate piece of graph paper. Okay, just got a couple problems that we're going to do. The next question is we're going to figure out if the point 6, -3 is on, inside, or outside this circle, x squared plus y squared equals 45. So if you think about it, if I'm thinking of circles centered at the origin, every point on my plane, every point on my grid is on exactly one circle. Points really far away are on really big circles. Points really close to the origin are on really small circles. I just want to check if this point is on the circle. We're really good at checking if points are on lines or circles. We've been doing that all week when you were in school with left side, right side checks. I'm just going to do the exact same thing here. So the left side is x squared plus y squared, and the right side is 45. Let's plug in our point. I've got an x coordinate and a y coordinate, and we're going to check if left side equals right side. If it does, the point must be on the circle. So I have 6 squared plus -3 squared. 6 squared is 36. -3 squared is -3 times -3. Negative times a negative is a positive. So the left side equals the right side. So that means the point is on the circle. So I could say LS equals RS. Therefore, the point is on the circle. If the left side is bigger than the right side, and maybe I'll add a little thought bubble note down here. If the left side is bigger, that means the point must be on some circle with a bigger right side or a bigger radius. So that means the point is outside the circle. And if the opposite is true, if LS is less than right side, RS, then the point is inside the circle. The point is on some other circle. It's got a smaller radius. Okay, I'm going to show you kind of what I mean on Desmos. So let's look at that last example. We were looking at x squared plus y squared equals 45. Oops, there goes my phone. And we were looking at the point 6, -3, and we determined that it was on the circle. So if I plug in that point, and we can see it's that little blue dot on the circle there. If the point had been inside the circle, imagine a point like 2, 2. That's when the left side is less than the right side, because the point 2, 2 is on a circle, but it's on a much smaller circle, I think, and we can just kind of look at it here. I think that's on the circle x squared plus y squared equals 8. So every point is on a circle, but it's some different size. So the point 2, 2 is inside my red circle, but it's on my green circle. And it's also outside, for example, an even smaller circle. So here's a purple circle, the radius of just 1. And my blue point is outside of that. So every point, using a left side or right side check, we can figure out if it's inside, outside, or on the circle. We're just going to do one last example. So I'm going to switch back to the document camera. And in this question, we're told that a circle centered at the origin goes through the point -3, 4. And we're going to use that information to determine the equation of the circle. So anytime it says equation of a circle, well, okay, I know the form of that equation. That's going to be my target, x squared plus y squared equals r squared. Now, I don't know the radius. It's not given to me. I don't know r. But I have been given x and y, so why don't we plug those in? -3 squared for x, and 4 goes in for y, equals r squared. Now I've got an equation in one variable. I can solve this for r. -3 squared, -3 times -3 is 9. 4 squared, 4 times 4 is 16. We're always going to have positive numbers. Equals r squared. So r squared equals 25. Now we could keep going. We could square root this to figure out that our radius is 5. That's some nice information. I don't actually need to, because remember, eventually we want to say, well, the equation of the circle is x squared plus y squared equals 25. So there's my equation of the circle. X squared plus y squared equals r squared. And I found out what r squared was by plugging in a point. So because every point is only on exactly one circle centered at the origin, if I know a point, or if I'm given a point in a problem, I can figure out both the equation of the circle and the radius. So again, let's take one last look at Desmos. So in that question, what we found out is I gave us a point. So I'd given us a point -3, 4. And we found out with a little bit of algebra by plugging into the equation of a circle. It was on the circle x squared plus y squared 25. And you can see that the radius is 5, which means that the distance from the center here to the outside here is 5 units in any direction. So that's all there is for circles. Circles are more straightforward because any circle that has a center at the origin at 0, 0, we only need one piece of information to figure out everything else. So again, go into Google Classroom, try some problems from the textbook, try the quiz on Brightspace, or send me an email if you have any questions, or log into our virtual study hall today. Okay, best of luck. Hope to see you in class soon, and have a good weekend.